Today's video is section 2.4, the chain rule, but it's a continuation. And actually, since we skipped a day because of the presentation, I believe this will now be 9/11. Anyways, homework for this is section 2.4, 68, 71, 73, 74, 81, 86, 88, 90, 95 through 100. So let's review. In fact, this is going to be a very short video, and a lot of it is review. So find an equation of a tangent line to the graph of f at the given point. So again, what does it want? It wants the entire equation of the tangent line. So the first derivative will give us the slope of the tangent line, and then we'll have to use point slope form to find that equation. So let's see what our given function is. F of x equals 9 minus x squared quantity to the 2/3 power at the point 1, 4. I see why this is in here, because you're going to need to use the chain rule. Let's go ahead and let's do this problem. So let's take the first derivative, take the derivative of the outside, copy the inside, decrease that power by 1, times, now I'm going to take the derivative of the inside, negative 2x. I'm going to go ahead and rewrite this just a little bit. So this is in the numerator, this is in the numerator, this is denominator, and that's denominator. So it's negative 4x over 3 in a cube root of 9 minus x squared, right? Negative 2x times 2, denominator, denominator. So let's go ahead and get that slope of the tangent line to the graph of f at 1, 4. So that's negative 4 in the numerator. 3 times, what is that, the cube root of 9? I'm sorry, the cube root of 8. Cube root of 8 is 2. Oops. There is the slope of the tangent line to the graph of f at the point 1, 4. Y minus y1 equals slope times x minus x1. So I have the slope of the tangent line, and 1 and 4. There it is in slope-intercept form. I don't know, maybe the back of the book, I don't remember. Might want you to leave it in point-slope form. Sometimes they even leave it like this. It's good to practice all the way through. There's one other form that they could leave it in that you might not be familiar with, and that is standard form. So standard form looks like this. And the reason that A, B, and C are capitalized is because they do not want any fractions. They only want integers. So it's set equal to 0, and there's my x and my y. So let's see. I guess we can take this one here. So I want to set it equal to 0, so I'm going to put everything to the other side. So what would that be? Let's get a positive 2/3 x and a positive y and a negative 14/3 equals 0, right? So I put this over here, it's positive. I put this over here, it's negative, and I put it in the order of x, y, and the constant. And so now I've got to multiply both sides by the common denominator, which is 3, which I can do. I'm allowed to do that. So I do it on both sides. So that's 2x plus 3y minus 14 equals 0. There is the same equation of the tangent line to the graph of f at 1, 4 in standard form. Next, here's another review item. Find the second derivative. Again, I see why it's here, because I'm going to have to use the chain rule. So let's go ahead and use the chain rule and just find the second derivative. Let's go do the first derivative. I leave 2 alone. So now I'm going to do the outside. Bring down the 3 times the quantity x squared minus 1, reduce that by 1, times, take the derivative of the inside. I'm going to go ahead and clean that up. So 2 times 3 is 6, times 2 is 12, 12x, times x squared minus 1 quantity squared. Well, now, to take the second derivative, which is denoted like this, I need to see that this is a product rule, right? This, because I got the x in it. I can't just leave it here. Now this is a function and this is a function. I have to use product rule. So take the derivative of the first, leave the second. Plus, leave the first, take the derivative of the second. And I've got to do the chain rule on the second. Reduce it by 1 times the derivative of the inside. And now I'm going to clean that up. Let's see here. So here is that technique that I did in the video, last video, and I said, oh, it's coming up and it's not here yet. Well, here it is. Please denote that 12 is being multiplied to this. Here's the only plus sign. Then this is being multiplied to this, which is being multiplied to this, which is being multiplied to this. So what I can do is I'm going to take out a common factor here. I'm going to go ahead and take out the factor of x squared minus 1. Just one of them. I'm going to take out 1 from here, the only one I have, and 1 from here. I can also take out a 12 from here and here. That's all that they have in common. What's left? So out of this term, because there's only 2 terms, terms you can tell are broken up by plus or minus. So here's one term plus another. All I did was factor out what's in common. They have a 12 in common and x squared minus 1 in common, that factor. What's left here is an x squared minus 1, one of those. Here's my plus. You see I used the 12. I took one of these, so I have left is an x times a 2 times a 2x, right? That's in the second one, because I just factored out a 12 and an x squared minus 1. I still have the x times the 2 times the x times this 2. Oops, it's the second derivative. Clean that up a little bit more. X squared minus 1 plus 4x squared. Almost done cleaning this up. 12 times x squared minus 1 times 5x squared minus 1. We can go ahead and leave it like this. So I show 3 factors. This from here to here is a technique we have not done before, where I noticed the same factor of x squared minus 1. Take that out, factor that out. It's okay, there'll be plenty more opportunities for me to go over it and for you to learn it. Evaluate the second derivative at the given point. Evaluate means go give me an answer. Where at the second derivative at this point. So let's go do that. First, let's go get the second derivative. So chain rule. Take the derivative of the outside, that's negative sign, copy the inside, times the derivative of the inside. I'm going to clean that up a little. Negative 2x sine of x squared. Now I'm going to go ahead and find the derivative. Please denote that this is now product rule, and inside this one we have to use the chain rule. So let's just do the product. This one times this one, each of those functions. Take the derivative of negative 2x, negative 2. Copy the second. Plus, leave the first. Take the derivative of the second. Now I'm going to have to use the chain rule. Derivative of sine is cosine times the derivative of the inside. Now I'm just going to go and clean this up. Okay. So now let's go ahead and evaluate this at 0. Let's see, sine of 0. This is 0, radians of 0. Sine of 0 is 0. And then 0 times anything is 0. So I just evaluated that. And that is it for this evening. Thank you.